Hello everyone, welcome to another video. In my previous videos, I talked about neural networks and its classifications. I gave a little insight on neural networks and its classifications. In one of such recent videos, I explained about convolutional neural networks, a category of neural networks. Now, before getting into some detailed explanation or detailed insight of the neural networks and its classifications and how do those neural networks work, let's portray neural network a little bit once again. So neural networks are basically a group of artificial neurons that are designed to imitate the operations or actions done by human neurons. So it is basically a software solution. Now these neural networks, they leverage the machine learning algorithms to mimic or imitate the human neurons. Along with its functionality, that is, it works efficiently like human neurons, its architectural structure or its architecture is just like the complicated human neurons. Now, there are several neural networks. There are several categories of neural networks. I'll point out those later on. Now, neural networks are more efficient in processing the data such as voice, images, visual memories, patterns, and it is more efficient also in solving more and more complicated problems than the traditional or conventional computers. Now, let's categorize the neural networks in 6 major categories, which are convolutional neural networks, deconvolutional neural networks, recurrent neural networks or RNN. Also convolutional neural networks may be abbreviated as CNN. Feed-forward neural networks, modular neural networks, and generative adversarial neural networks. Now, the convolutional neural networks have been explained already in my one such video, which I already uploaded in our channel. You can watch those things. You can watch the convolutional neural networks. I'll put it in the I button. You can watch it. Now, so what is the basic architecture of neural networks? So the neural networks are basically, the neural networks have basically the input layer, the one or multiple hidden layers, and one output layer. So the hidden layers are basically placed in between the input layer and the output layer. So in between the input layer and the output layer, there may be one or more than one or multiple other hidden layers. Now, in case of the input layer, the duty or job of the input layer is to basically take up the data. The data means the languages, the voice, the image, the visual memory, the pattern that is shown to the neural computer. So those things, it basically takes up those data and it processes those data in that tier and it transfers into the next consecutive tiers, that is basically the consecutive hidden layers or layer, one or more or maybe present there. So and then it basically processes those things, and those things are processed, those data are processed in between in those multiple hidden layers, and then it is being transmitted, it's transmitted rather into the output layers, and we get the prediction, it predicts the output value. Now the idea is, in the input layer and the output layers and the hidden layers are basically interjoined with each other in this neural networks, and it basically forms a very not one, basically it forms lots of extremely complicated networks. Those are interjoined with each other, and it builds those neural networks. Now in case of convolutional neural networks, there is one such category of neural networks which deals with basically visual patterns, which basically processes or traces or predicts the visual patterns or process those things. So in that convolutional neural network, the layers are, there are multiple layers, those are convolutional layers, and basically it's a perceptron. And that CNN, that is convolutional neural networks, in that CNN rather, the convolutional neural networks, the layers are maybe interjoined with each other or pulled. Now those CNN have very high implementations in the visual pattern detections, and more efficient problem solving approach than conventional computers rather, and those things are very, very important, and it has wide applicability in today's world. Now let's understand the architecture. Let's get into the architecture of the neural networks in little bit more detail. Now as I have told, the neural networks have been constituted or comprising of several layers, like input layers, the hidden layers, and the output layer, right? So there will be one or more hidden layers in between the input and output layers. Now the idea is, those input layers are basically comprising, or those input layers rather comprise of several node layers or nodes. Now what are those nodes? Now the nodes are basically the artificial neurons. Now the node layers are interjoined with each other in that network, in those layers. Now those nodes basically have a threshold and a weight. So every node, each and every node, one single node, each and every node has its own weight and own threshold. Now what are the meaning of those things? Now the idea is, when the nodes take up those inputs, the data, it processes the data that are shown to the neural computer. Those data are processed rather in the input layers, or more precisely by the node layers, and then if the data that is taken by the nodes, if it basically crosses the threshold of the particular node or nodal layer, then that particular node is activated, and that data is transmitted to the next network or next consecutive tiers, or more easily the next hidden layers, right? Now this is the very important thing which we must understand. If the nodes are activated, or if that exceeds the threshold of the particular node, then only the node is activated, and then only the input that is being taken, the input data that's been taken rather taken into the node layers or input layer more precisely, then then it only gets transmitted into the next hidden layers or next layer, next network, right? Now this is a very important thing. Now, if that does not exceed the threshold of the particular node, then the node is not activated. In that case, the data will be processed and transmitted into the will be transmitted rather into the next layers, next network. Okay, next tier. That is very important part. Now this is the more long short idea of how the architecture of neural networks looks like. This is a very important thing. Okay. Now let's try to the beauty of neural networks basically it has wide applications rather than the neural networks are very much applicable and is very much important. It has a more efficient problem solving approach or more efficient in the processing the data, the input data than the conventional or traditional computer. Now, when the data are being taken by the inputs, another important thing is that in neural network rather is that when the data are being taken into the input layer or in the nodes, the node layers, so it happens in a consecutive fashion. So what does it mean? It means the data are being taken in the nodes or the input layer. If the node is activated, if it exceeds the the threshold, then only the data will be processed and will be transmitted into the next network or next tier, next consecutive tiers rather. Then it will be processed and in that layer also, and then it will again it will again be transmitted rather into the next consecutive layer, and so on and so forth. So this is very important thing. It's basically it happens in a consecutive fashion. This layer, then that layer, then that layer, then that layer, then basically we will get to the output layer. We will have the prediction. Now this is the idea. Now, if we think about now basically it leverages the neural network basically leverage the several machine learning algorithms actually to mimic or imitate the biological signal processing of the human neurons. This is very important. Okay. Now the idea is if you basically, so what are the differences between rather conventional computer and neural computer? Now, in case of conventional computer, the conventional or traditional computer works sequentially. It takes up the data one by one, and then process and then get the output, and then again the next one. So basically sequentially, not simultaneously. It can't take up and process those data and predict output of several things, several inputs simultaneously. It's not possible. But in neural network, it is possible. It works simultaneously with very high efficiency and precision, and the idea is it basically leverages several algorithms, advanced machine learning tools or algorithms when doing those things, when processing those data and basically predicting and doing intermediate things as well, and when predicting the output. Okay. Now this is very important. Now, if you see, in case of traditional computer also, it takes the logic functions and work like this. In case of neural computers, it basically takes up the raw inputs. It take up rather raw inputs and process those data and basically predict the outputs. Now, in the conventional computer, the data that are shown, or the pattern, the visual pattern, or other patterns maybe, which are shown, the languages maybe which are shown or which are instructed, basically which are put as instruction into that conventional computer, it will act accordingly. But in neural computer, it basically it programs itself to process those data and get to the predictions or predict the output values using those advanced machine learning tools simultaneously. Now this is the beauty, and for this, and also in case of traditional computer, what is the possible? It will do. It can do out of the box things. Now, in case of neural computer, it over time one has to, train the neural computer over time to have more and more precise and efficient predictions. So that is thing. And fine tuning of such machines basically pay as very high dividend and very good computing tool in today's world, in today's things. Now this is very important. Now let's get into a topic: how do the neural networks work? That is very important also. How do the neural networks work? So there are mainly four stages which are key, key contents or of working of neural networks or neural computer, which are firstly associating, secondly classification, thirdly clustering, and fourthly, the fourth and finally, the predicting the outputs. Now let's explain this things a little bit. Now in the associating part, it basically whenever we are like human neurons, basically the neural networks or neural computers are basically are shown some inputs or shown some languages, shown some data, some images, some various patterns maybe. So those they basically, so that whenever those are put into the or shown to the neural computer, it takes those things as inputs and it starts associating those things as its memory. Okay, it basically preserving those things as memory, right? Because it's associating those inputs which are being put into the system, into the neural computer, neural networks. So this is the associating part. Secondly comes the classification part. Now we are suppose if we put several visual memories, visual patterns rather, or several languages, several images, several videos, several audios, whatever. So if we put those things into the system, into the neural computer or neural networks, so it tries to classify those things as several predefined classes. Now thirdly comes the third stage comes clustering. Now what is clustering? Now clustering means, suppose it has now at this point the neural computer, neural networks, we have already put the inputs right into the neural computer, and it has now by detecting rather several unique aspects of those inputs, like visual memories, like other things like visual patterns rather, languages, voice, videos, etc. So it tries to cluster, or it tries to group up those things on the basis of several unique aspects that it traces or detects among those among those inputs or datas that are put or shown to the neural computer or the system. Now the last thing or final thing is that prediction. Now we have already put the inputs, it has processed, it has processed, and if it crosses the threshold, it transmits those data into the next consecutive tiers, and so on and so forth. Then it basically calculates, does everything in those layers. Now in the final part is the predicting the output. Now in the output layer, it will, after doing all such calculations in between, and the hidden layers and the upper layer, it will basically predict, it will evolve, it will basically emit the output of it will predict rather the output of those things, whatever we have put into the system, into the neural computer. So that is how those are the stages of the neural computer. It works just like that. It basically by leveraging rather several machine learning tools or algorithms, it basically mimics or imitates the signal processing, biological signal processing of the complicated human neurons. This network is, or architecture is also just like the human neurons, and this is a very beautiful thing. And these things make all these things make it even more efficient in processing data, and more efficient in solving more and more complicated problems, tracing the particular pattern and matching it with the closest enough memories, and predicting the value, predicting the pattern rather, or output. So all these things happen in the neural network. So all these things make it a very important tool into this computing world, and it's very important. We can use it in also, if you see in lots of computers or PCs, laptops, or even smartphones also. You see there are facial lock system in your systems or computers, or maybe in your laptops or smartphones, even facial lock systems. Now in those things, what happens, the actual thing that is behind the screen, that is working behind all these things, is convolutional neural network, a category of neural network that basically that is powered by the AI powered visual generated project. So that is very important. It basically it will rather predict the visual patterns that is closest to the input that is given to the system. Like, that is very important. So also if you see on your Google interface, whenever you open your Google on your system, maybe computer, maybe tab, or smartphones, even Android or iPhones, you see there is an option in the right side of listening. Like, if you say something, it will record this thing and it will put into the search, and it will give you the result, the outputs. So the thing that is doing all such things behind the back of the screen is convolutional neural network. So convolutional neural network, so CNN, is responsible. It's widely responsible. It's actually responsible behind all these things. Also there are RNN and recurrent neural networks that are basically it is responsible for the natural language processing. Now, if you say something, if you write something on your Google interface, it will give you the search, right, the predicted results, right? So all those things are done by the artificial intelligence back of the screen on the neural networks more precisely. That's very important. So today in my video, what we have learned how the architectures of the neural networks, what are neural networks actually, then the architectures of the neural networks, the differences between the conventional and neural computers, and then how do such neural networks work. So that is very important. Okay, we'll meet in another video shortly. Till then, bye. Good luck.